Hi everyone. This is a drawing that I really treasure from a former student of mine. And today we're going to be talking about problem solving. So I found this quote from graduateland.com, and they say, problem solving is valued highly in our economy. As a result, demonstrating strong problem solving skills can be the secret to success when applying for a job and throughout your subsequent career. In 4.5, we are working with systems of linear equations and problem solving. And by the end of this section, you should be able to solve problems that are modeled by a system of linear equation. We have our general problem solving strategy that we first discussed in chapter 2. And the first step is to understand the problem. We have to read and maybe reread the problem a few times. I like to circle what the question is asking for, so that's my main goal, and underline any numbers or anything that help tell us the information that is known. Then we want to choose a variable or in this case, two variables to represent those unknowns. Constructing a drawing really helps when you can do it. Sometimes doesn't make sense for the problem. And proposing possible solutions. Think about what makes sense for the problem that you're looking at. If you're talking about distance, that can't be negative, right? A rate can't be negative. If you're talking about the rate that somebody's jogging at, it wouldn't be 1,000 miles per hour, right? So that's what that means, thinking about what the answer could be. Our second step then is to go ahead and translate the problem into two equations with two variables. Once you have those equations that relate your knowns to your unknowns, you can move on to step 3, which is just go ahead and solve the system of equations. Remember, there's 3 different methods for that. We talked about the first method, which is graphing. And it's kind of messy, right? It's not precise, so we don't usually want to use that method. Our second method is the substitution method. Solve one equation for one variable, and then substitute that into the other equation for that variable, which leaves you just one variable in your equation, and you can go ahead and solve. Our third way to solve a system of linear equations was the addition-elimination method, right? If your two equations are in the standard form, x and y are on the same side, right? You can get one of the variables to have the opposite but same number coefficient, so that when you add those two equations together, you end up with an equivalent equation, but it only has one variable which you can solve for, and then go back to one of your equations and find the other variable's answer to complete that answer for the system. And the last step is super important step, right? You have to interpret your results. You can't just say x equals this, y equals this. What is this problem asking you for? Make sure that it makes sense for the problem, it checks out, and absolutely state your conclusion, which means answer the question, right? So in the next video, we'll start with the first example in our notes on finding unknown numbers that have a certain type of relationship.